It says I'm live now. I don't know if I was live before that, but regardless, I suppose this should work. Let's just actually make sure we have audio. This sounds completely horrible. Do we have audio? Is this working? It says I'm live now. Okay. I just have a like 1 minute lag on my monitor, but it seems to have audio. So we're good. Right, so this here is a 70s, 80s printing press PCB made from a local printing company. They make all the phone calls. Did I just break something? Okay, that was actually the customer for this project. He had a bit of an issue. I have to go there tomorrow to clean some stuff up. So apologies about that. Where were we? Right, yeah, so let's actually get started. We got someone giving me money in the chat. Thank you, Atta. Says, now this is suitable Saturday entertainment. For sure. If we can actually get to the entertainment. Right, so let's have a look at this board and what it actually is and what we're supposed to be doing. And this is what I was doing when the phone rang. I've redone the workbench, so everything's in a bit of a mess. But this board is a power supply and general writing board for a brake unit in a big printing press. So what it does, or rather what the thing that this goes into does, is it controls the brake on a giant, like several ton roll of newspaper paper that they use to feed into the printing press. So if this does not work, once the big giant ton heavy rolls of paper start spinning, they never stop spinning. And if they never stop spinning after the printing press has changed speed or stopped eating paper, that means there's a lot of paper coming off the roll and going everywhere. So this is a rather important piece of equipment. It's controlled by a bit of an ancient computer board that hooks up to here, but this is very stupid. There's no processor type stuff. It's just a big power supply and some writing and a few relays. And this thing originally had a bit of an extra tiny board that went beside it, which has an overvoltage protection for the brake. It's a magnetic type brake. So it's a big inductor that just controls. Yeah, I think it's like a magnetic choke that just makes it brake mechanically. But there was a bit of a protection circuit. We've done away with that. But on that board, there's also a small RC filter to filter the PWM signal coming from the computer board here. And I've figured out how that works, and I've integrated that onto this board. So there's going to be a bunch of soldering stuff onto the back of this, as well as building my entire brake status monitor circuit on the back of it. So let's have a look at what this is. This is the big thing that we're going to be working on tonight. So this is a high gain, a Darlington optocoupler. This is a BC546 standard issue European transistor, and K5 here is this relay, which we are going to repurpose for our brake status monitor circuit. So what is the brake status monitor circuit? When they're changing rolls of paper in the printing press, they need to release the brake. At idle, the computer has slight brake activation over time to make sure nothing is allowed to suck paper or get the roll spinning out of control. It's a safety feature. And there's a manual switch that they go click on, and then they can roll it freely. However, in the original system, there was basically no feedback on that at all. And we are adding that functionality because there's a PLC keeping track of everything, and they had like some kind of ghetto switch setup where they just had the switch for the brake hooked up to the PLC monitoring contacts, but there was no actual feedback if for instance the board was powered at all. If you broke power to this to this board, and it's a CPU board, the brake would be deactivated, and if the brake was set to on the switch, it would still register as active braking, and you could turn the printing press on with no brake and have a disaster on your hands with out of control spinning rolls of paper. And this circuit remedies that by being since it's pulling a relay coil, it is unable to report a working brake without power on in the actual machinery. So we're adding a nice safety feature, and this is a very, very simple circuit, and we are going to mount it on the back of a board with no extra PCB, no nothing. It's just going to be mounted on and glued in place, because it's just a 1, 2, 3, 4 resistors and a transistor and the opto-coupler. So we're going to be scratching some traces, we're going to be adding a wire and gluing everything in place. So to go through the theory of operation of the circuit we're going to be adding, we have an input here for the opto-coupler, and this is going on a monitoring line that's internal to the processor board here, and it's a very, very low current supply. We can only draw less than a milliamp, I think, out of it. It was a while since I designed this, I don't really know, but do 24 volts over 220k and you'll get it. It's like a milliamp max we have to work with, and if we draw more than that, it's actually going to register wrong in the little internal computer here, and it's not going to work. So I've spec'd a HCPL 4701, a very high gain opto-coupler to do the actual monitoring. This is a up to 3500 CPR. Is it CPR? Up to 3500% CTR, current transfer ratio opto-coupler, so it takes very little current to drive this LED enough to trigger the output. So when we have a 24 volts over here, we are going to have the LED going on. We are going to be pulling this transistor, which is going to be pulling this relay. So we actually have a Darlington coupling inside the opto-coupler and another transistor on top of that with a HV of a few hundred, drawing our relay, which only draws about 2-3 mil. No, oh no, I think it's like 11 milliamps in the core of this relay. So this is actually a really high gain circuit, which somehow I actually got to get be stable on the first try, even though we have a 1 meg pull down resistor on the base of this transistor. But yeah, before we get to any of that, we need to just give this board a bit of an overhaul, because all of this stuff is original. It's these tires are from the late 70s, early 80s, and original caps, some have been replaced. On this board they have not. So we need to swap all the caps, we need to redo a bunch of solder joints. We have one of these terrible red plastic caps here, which are notorious for just drawing out over time. But aside from that, these boards have been incredibly reliable. I've had a couple of these read relays fail, which I'm using for the brake monitor circuit, but that's actually not critical. The phone call I got at the beginning of the stream where we were actually discussing this, because even if a brake monitor fails, you can still run it. You just have no safety interlock on the braking. So yeah, let's just get at it. We're going to be doing a small modification to the board here to get some more modern 2-pin capacitors in there, and we'll go from there. So right now this is just going to be general service, I guess. No modifications for a while, because I want to get the what's the word? I want to get the overhaul done before we start doing the modification. These boards are a bit annoying to solder as well. They're rather high thermal mass plated through holes. with lots of copper. I'm going to bring in, give me a sec, let me see if I can get this window capture here for my reference images, so you can see some of the stuff we're working on. Let's see what we can do. Add window capture. Sure, let's make a new window capture, and hey, it's the right one. Oh, that's so that's beautiful, but there we go. So we're going to be adding those blue jumper wires you can see to the left, the green jumper wire as well, and then we're going to be adding the circuit in the middle and the blue capacitor resistor to the right, and that's our ultimate goal. After doing all of our modifications, you can go to the bottom, please. Move up. Move up. Oh, come on. There we go. So that's a picture of a board for our entertainment. I'm going to have issues with the screen real estate here to get the YouTubes and the streaming software and the everything. Gonna give a pop-out chat, thank you very much. Pop-out chat and my picture on the big monitor. Off-grid Aussie Pepper is asking, when can we see an update on house battery and house renovations? I'm going to be tackling that when I have time. I've been very, very busy lately, and I was sick for like half of January, and I was dealing with some life problems basically all December. Right, so the first order of business is getting these stupid big caps off. They are annoying. We need a very big solder tip to get them. I could actually use the TS100 for that because it's very high thermal capacity. But my adapter for that is in the van, so never mind. Never mind. Some solder water. Robin Vandenide says, now that's a proper bodge, and indeed it is. We've actually, because this is such a critical piece of equipment, we've had this test running for over a year. The first one of these boards, we just modified one out of, I think, 6 roll brake controllers, and installed a board that's identical to the one you see in the picture with my modifications on it, and it's been running fine for an entire year, daily use, printing many tens of thousands, if not hundreds of thousands of newspapers. So this is a very well field tested design. It's going to work very well. I'm not worried. It's barely even a budge. So getting these capacitors off is very troublesome, to say the least. Getting the desoldering pump to actually suck them out is usually not happening, because there's just they are snap-in caps, so the legs are very bent and fat. They're pressing up against the side of a board, of a plated through hole. So usually we can suck most of the solder out, but not all of it, making it basically impossible to remove in any sort of controlled manner. But we'll give it a go. Sometimes it works, sometimes it does not. Oh god, we can't do automatic exposure, that's just bad. So let's see what this was going to be. That actually looks pretty good. We got a lot of it out. By far not all, but you never get it all. The problem with just using force to get this out is you will destroy the PCB. Since we have plated through holes, if you rip this, you are going to rip the through plating as well, and that makes it impossible to solder it to the top layers once you're done. And these old PCBs, they don't take kindly to hot air, so it's very difficult to actually remove through-hole components. On more modern PCBs you can just use hot air, melt all of the solder joints at once. That did not go well. But these are tried on the first one I did, and hot air on this just turns it into a burnt mess. I actually have a capacitor here to support this while I'm working on it, so I might as well use it so it doesn't tip all over. Off-grid OSI Prepper asks leaded solder. Yes, this is something that's 40 years old by now. Very leaded solder. Well, that's not a happy desoldering pump. Someone says mini solder bath. I suppose that could potentially work. Right, now this one is not going to come nicely, so we're just going to have to walk them out one leg at a time. So I'm applying force on the capacitor, just leaning it in one direction at a time. Now, the good thing about having a very high thermal mass board is, as you might have noticed, if I'm quick, the solder will remain molten for a while after I remove the soldering iron. So if I do that and then quickly go that, I can get a bit of pull on both of these. You can't get greedy. Another phone call.